Are you good? Okay. All right, so this is x is less than or equal to 0. Okay, and then the bottom one's going to be 3 plus a half x, so I'm just going to write it as 0.5x. Get my parentheses in there. Get my parentheses in here. And my interval is greater than 0. X is greater than 0. Is everybody awake? I feel this class is kind of zoning today.
No, it's Tuesday.
Well, I thought this thing happens on Mondays. Oh, actually, you guys are seniors, so it happens every day. That is to say, senioritis has already set in. Yeah, Laura, you look awfully tired. You look tired. Did you say you were tired? Oh. Okay, so the window you want is -1 to 4, so let me go change that. I'm going to go -1 to 4. Let's make this standard. -10 to 10. And if I graph that. Did I do this thing right? Yeah. Okay, that's the window you're supposed to address. So you can see that something funky is happening out here. Right? So let's go zoom in there. Okay, so you really have to think hard about this, okay? Because the calculator is making you believe that there's something funky going on here. Okay? Well, is something funky going on here? Let's take a look at what's happening when x is equal to 0. From the top one, if x is equal to 0, what is y equal to? 3. For the bottom one, let's use black. For the bottom one, when x is 0, what do you get? 3 as well. Is there a discontinuity there? And they're both meeting at the same place? Laura, are you with me? Okay. Maybe I need to graph this thing by hand. Okay. Let's go do this by hand. 3 minus x, so it's going to have a negative slope. It's got an intercept of 3. And here's my top graph. Okay? My bottom graph is going to be this guy here. Hey, your stuff's up there. Oh, I don't know, where is it? Okay? It starts out at 3, doesn't it? Okay, it starts out at 3 and its slope's going to be... What's the slope of that line? Hello? What's the slope of this line here? 1/2. Okay, so it's going to be like this. You guys with me on that? Okay. Do you see that there's a closed circle at 3? So this is 3. Let's say that this was -1, and let's say this was 4. Okay. So to look at the continuity of this graph, and this is something that I'm really supposed to teach you today. I was supposed to teach it yesterday, but period 1 fell asleep on me, so I stopped. And I'm going to do it today. But this is a good lead into what I'm going to teach today, okay? So to look at the continuity of a function on closed interval, you've got to look at it over the open interval. So is this function continuous over this interval? Yes. Okay? For closed interval, let's postpone that because I'm going to teach you that in a minute. Okay? What you have to do for closed interval, so John, wake up. Yeah, see, I've got a sleep radar, zone radar, Twitter, texting, yawning, all those radars keep going. Well, I saw her sleeping. That's still a radar. I see it. Yeah, so let's worry about the closed one after I teach you today. So, Laura, what was your question about this problem?
I understand that it's continuous, but I would understand when you look at the whole graph, it's continuous for more than just the negative 1 through 4.
That may be. But they want you to focus on minus 1, 4. They want you to just look at that part of the graph. Yeah, that's all they're asking you. Just focus on that, what's happening in there. I don't care what's happening outside it. Whether it's continuous or discontinuous outside, I don't care. Just focus on that part. Okay? So it's like part of the instructions of the question. All right, so this is a good lead into today's lecture then. Let's go do that. So yesterday we talked about continuity of a function at a point. And there were 3 rules I gave you, Chris. There were 3 rules I gave you. Do you know what they are? Look at your notes. See if you have them. Okay, that's one. FC is defined. Okay, a limit exists. That's right. If the limit is equal to f of c, then the function is continuous at the point x equals c. Okay, so that's the definition we've got to keep in mind. The other thing on this slide here is brackets versus parentheses. Does everybody know the difference between the two? Yeah, Stephanie.
Brackets inclusive.
Nice.
And the parentheses are exclusive.
That's right. So brackets are inclusive of the points a and b. Okay. Parentheses are not. So what do I mean by that as far as the function is concerned? Let's take a look at this graph here then. Okay, so here's a function. And I'm saying it's a function over the closed interval a comma b. Why do I say brackets? Why do I say brackets and not parentheses? Leila? Like how can you tell by looking at this picture? Sorry? There are closed circles at both ends there. That's a closed circle and that's a closed circle. You can see that, right? Okay, so this is closed interval. So in order to look at the continuity of this function over this closed interval, so take a look at this graph here. Is this continuous at 0? Yes. So the composite function is continuous at 0. Okay? So that's all I have for today. What I would suggest very strongly is you've got about 10, 12, 14 minutes right now. Start working on your homework. If you have questions, this is the time to understand. You can get those questions answered. Because tomorrow I'm doing a really important theorem. Okay? Doing a really important theorem. Karthik, stop zoning in my class and sleeping, man. Pretty soon you're going to start snoring there.